Hi, all. Well, thank you for joining us on this journey, this connected intelligence journey. We appreciate you taking the time this afternoon, and we hope that you'll find the excitement and energy off of this presentation contagious, because we'd love for you to actually join some of the additional sessions as well. For those of you who joined us yesterday, we do appreciate it, and that you're joining us a second time. So please feel free to send us any comments, any thoughts about the presentation, and also any questions that you may have, and we'll be more than happy to follow up on them. My name is Tom O'Sullivan. I'm the Senior Vice President of Client Engagement at DataPoem. I've been with DataPoem approximately 2 years. I have extensive experience in the market research and analytics industry. I've worked with companies such as Nielsen. I've worked with Symphony Advanced Media, which is part of the Symphony Technology group of companies. You may know some of the companies under that banner, which are IRI and Simmons. I've also worked with a company called Analytic Partners, and I also worked with a company called T-Vision, which is in the attention-based space in television viewership, which is actually a hot area right now. I worked with Fortune 500 companies, helping them, and I should say on the agency side as well, I work with their agencies, helping them leverage data and analytics for revenue growth. So before we jump in, foot first in this one, I'd like to just give you a brief overview of DataPoem. And I'll say brief because we have two co-founders of the company on here, and they can do a heck of a lot better job than I. But I'm just going to touch on this briefly for the sake of just a little bit of background. So DataPoem is a comprehensive connected intelligence and growth planning measurement and optimization service used by Fortune 500 companies. It is designed to empower data-driven decision-making and agile marketing strategies by revolutionizing the use of causal AI and neural networks. And that's what we're going to spend a significant amount of time on today. To help educate clients on connected intelligence, throughout the month of November, DataPoem will be hosting a series of webinars exploring how breaking down intelligence silos within companies and integrating them can actually transform an organization's approach to accurate forecasting, enhanced marketing strategy, planning, access to granular information, and agile business insights. And then finally, all of this leading to business growth. This is, as I said, is the second session in our webinar series. We have 3 more to go. So we'd welcome you guys to participate in our future webinars as well. This webinar is entitled Causal AI, the key to unlocking siloed intelligence. In today's session, we'll explore how causal AI serves as the foundation of connected intelligence, revealing relationships between previously isolated data points. I'm sure your company does not have isolated data points, but most companies tend to in some way, shape, or form. We'll discuss how clients use this breakthrough technology to unify disparate business units, leading to more cohesive strategies and operations. I have the pleasure of introducing you to the speakers today. First off, we have Bharath Gaddam. He's one of the co-founders of DataPoem, which was actually founded in 2019. Bharath has a vast experience of over 20 years working with global agencies like Omnicom and IPG, working with iconic brands such as McDonald's, Nike, Domino's, Dove, Volkswagen. So he has a wealth of experience across the board. And part of the reason why DataPoem was developed as a company was based upon some of the frustrations that he had received in terms of receiving the information in a timely and proficient fashion. Bharath's diverse industry experience and hands-on work has solidified his understanding of consumer behavior and the evolving marketing landscape, leading to his creation of DataPoem. Our second speaker for today is Chinmay Joshi. He's the co-founder and chief AI officer at DataPoem. Chinmay has over 24 years experience in technology, AI, and product management. Before starting his journey with DataPoem, Chinmay had a successful career spanning across various industries and roles. He serves as VP AI products at Sonasoft Corporation. He was a co-founder and VP of products at Spotify Inc., and was the senior director of operation at GrowFit. His diverse experience ignited his passion for leveraging AI to uncover the causal relationship between data points. We are thrilled to have both speakers here today. Before we jump into this, what I'd like to do is just a few housekeeping chores here. First off, all attendees, you'll notice that your microphones are on mute. So don't worry if the dogs bark in the background or kids jump on your lap. We won't hear them, which won't be a problem overall. But we also encourage you to send any questions or any comments on this screen. You'll see on the upper left-hand corner, there's a Q&A section. Please feel free to just drop some questions in there, and we'll be sure to address them either during the presentation or thereafter. So with that, I will change over to Bharath.
Hey guys, thank you so much, Tom. Hi, Chinmay.
Bharath, we don't hear you.
I think I can hear Bharath.
Yeah. Arpita, can you guys hear me?
You're good now.
Yes,
Okay,
you're good.
cool.
You're good.
Okay. Hi guys. Thank you so much for joining. I know a couple of you guys have attended yesterday's session also. We'll do a quick recap of yesterday's session also, but primarily I'm very excited about today's session because this is what actually today's session or the topic is actually what helped us unlock the value of causal AI to us, or connected intelligence to the market. And my frustrations, and like how Tom said when we started Datapom back in 2019, our frustration of having siloed ROI metrics, not having a very granular outputs that we want as a planner to make actions or to even get outputs in a timely manner. Like, most of the times any campaigns or planning happens in a monthly or a quarterly manner. How can we if you get a ROI insight or optimization recommendation after 9 months or 12 months of the campaign, it's as good as it's becoming a postmortem. So that was the real frustration that we were going through it. And then we met Chinmay, who kind of led our way and shown us the path to causal AI. And Chinmay, what's your journey towards causal AI? How did you get?
Absolutely, Bharat. So basically, I've been into AI for a long time now. I think people only know AI from now a couple of years since the ChatGPT launch, but I've been involved in AI much, much before that. And in fact, my passion for causal AI got ignited in the last startup that I was doing, where I was building the AI platform. And one of the quests that I had at that point of time is that how I can use the causal AI framework using neural network, right? And find the causal impact of each and every input on the output. And this quest is just not applicable to marketing ROI. It's a ubiquitous problem statement. But when I met you, right, and when we discussed this problem, I think it immediately clicked because as you were explaining me the problem statement, the solution was getting printed on my head that this probably this approach I would take, and this is how we clicked so fast. And I think that's where we got started. So my passion is causal AI using neural network because that's the cutting edge for future, and we have to overcome it. The industry has suffered for a long, long time. I don't think they need to suffer now.
Yeah. And I also believe that, like you said, right, the problem statement of uh, why and how and what needs to be done is exactly the any business optimization problem, right?
Absolutely.
Whether it
Absolutely.
is
Bharat, it's just not the marketing mix models where this answer is applied, but when we look at larger umbrella within a business, there are multiple functions in the business. If you look at across the value chain, right from the sales planning to demand forecasting to warehouse and logistics and the factory manufacturing and the order placement to vendor, the entire value chain within the supply chain, I think the AI has a role, and this causal AI is applicable everywhere. So I think it becomes very imperative for us to crack it and use it and let the industry get benefited.
awesome. Okay, let's get into it.
Sure.
And would you want to explain while I'm pulling up the slide, do you want to give us the anecdote of what's the similarity between us and uh, what people know of today as AI, what they
All
experience on a
right.
day-to-day basis on ChatGPT?
You're
Then we
absolutely
can
right.
get into this.
I'll probably give a little more perspective than what you asked me. I would
Yeah, sure.
say
Let's go
six,
with it.
7 years back, when we spoke about AI, it's the linear regression which was considered as AI, and everyone using linear regression would say that they are doing AI, right? And for a long time that continued. Maybe machine learning came along, and people started using a bit of that also. But the black box stuff, etc., etc. People, there was no acceptability among the people for even the machine learning algorithms. And then came the era of ChatGPT, where we saw the magic unfolding right in front of us, right? We never thought that AI could do this. And when AI did that, it helped get that trust, or at least belief that yes, AI can work across all problem statements, across all the fields, right? So that's the journey. And but even now, I think the AI is understood as LLM, or generative AI. I would say AI is beyond generative AI, because you given the larger AI umbrella, there is time series data, there is computer vision data, there is language based data, and we see the LLMs, or the generative AI. They're only scratching the surface of computer vision and the language based language mining and generation of natural language. But time series is still untouched, and I think that's where we are innovating, Bharat, as you know, and as our team knows, and we are pushing the boundaries of innovation and making long strides every day.
Awesome. Okay, so with that, let me just take a little bit of a couple of steps backwards in terms of why causal AI is required for marketing planning, or why it is a must, right? So like we said today in the session, we're going to cover about the challenges or why causal AI. Then Chinmay is going to cover the causal AI framework, and we will do a case study of how once causal AI is applied and how is it benefiting the clients in marketing planning, optimization, and the richness of data. And then we'll wait for question and answers, right? So when we look at from a business perspective, right, uh, we all know that the consumer behavior has changed in terms of being an interconnected consumer. And for that consumer, if uh, the clients on the other side, if you look at it from the understanding of what consumer is doing and how is he reacting to different business drivers, one of the biggest things that we face from a organization side is that there is a huge silos of intelligence that is available. All right, organizations have geared up with intelligence at every functional level, but they're all siloed intelligences, right? So intelligence, which is primarily whether it is media ROI, there's a separate model, shopper ROI, a separate model, trade, a separate model, uh, and all of it is kind of disjointed and not actually unified in a way. And that is a and hence because of this, the challenges that the organizations face is that uh, they are not able to action any plans in a coherent and unified manner because it's all disjointed. There is an underestimation of ROI across multiple functions, multiple channels. The forecasting accuracy is not great. Uh, and my favorite thing of agility, right? We there is no agility in terms of decision making across the board from strategic level to tactical level. And more importantly, how can we optimize and allocate investments across different business drivers, whether it is traditional media, paid media, influencer marketing, and other forms of business drivers that the organizations has to go through, right? uh, those are the business challenges, and what we are trying to do is we are trying to understand how are these business challenges actually solved by causal AI?
Yeah.
And that's what the session is about. Let's go through it. Yeah, Chinmay.
Thanks, Bharat. Thanks for setting the context. I think why Bharat emphasized upon some of the problems that the planners, the media planners are facing. I think let's take a step back and see what people have done over the previous years to solve those problems. I think long ago, I think we people just used to do linear regression because that was the prevalent learning technique at that point of time, where the impact of input was considered linearly on the output, as well as the impact was considered siloed. So no interconnected impact, no non-linearity, but it was solving some purpose. At least we had something, then nothing. All right. Then obviously people figured out that linear regression is not the way to go. It is quite off. They tried polynomial regression to probably inbuilt some non-linear relationship between input and output. But polymer regression is very, very manual and very, very cumbersome because one has to come up with n number of assumption, how the non-linearity might be there, which order polymer it should be, or how the interaction should be. So while in the theory it sounded very well, but in practice, I think it was very, very hard to do. Fast forward some time ago, I think we had these machine learning algorithms, statistics-based machine learning algorithms. We also had this multi-touch attributions coming in, and in fact, even now, many companies that we speak about they are quite gung ho about multi-touch attribution. But really, what multi-touch attribution is doing is trying to overcome the challenge that the machine learning models has, because while machine learning models might model some of the non-linearity between input and output, I think granularity, because is still an issue. It cannot go at granular level, give insights, attribution at granular media level, and therefore, if we cannot do that for the past, obviously we cannot plan in the future based on that learning. So multi-touch attribution was probably one way that wherever we had the user journeys available, which was mostly digital footprint, there people try to use that and complement that MTA to MMM to at least get granularity wherever possible, right? That was happening some time ago. Fast forward now. So what's happening now? We know deep learning is in vogue. We know it may work. So let's see what data poem is doing, what problems data poem is solving.
Yeah, before the power of deep learning, Chinmay, I think we should just touch upon the challenges the present statistical model world actually creates for getting the answers, right? Why should
Right.
people move from existing statistical world to a causal AI world, right? Why should they do it? What are the challenges of the learning
Correct.
techniques which actually create the issues and hence creating the business issues?
And absolutely, I think let me delve more on that. Thanks for prompting me, Bharat, there. I think first issue being the multidimensionality. That is one of the gaps in the machine learning algorithm I just mentioned about, because we want granular insights. And if we want to have granular insights, the data has to be multidimensional. There have to be a lot of features which need to be fed to the model, right? Machine learning algorithms just fail to do that, right? And therefore, it cannot get you granular insight. It can only give you insights at a very top level, say channel level, right? Within digital, maybe it can give you at digital video level or digital social level. But can it go within digital video? Can it tell you the ROI of YouTube? Within digital social, can it tell you the ROI of Facebook or TikTok? That remains mystery. In fact, not mystery. That cannot happen with the classical machine learning algorithm because that's just not happening, right? So multidimensionality is a big, big problem. The second problem, like we touched upon, linearity, is that all the algorithm assume a linear impact between input and output, which obviously is far, far from the reality, right? And if we build that way, we are bound to fail there, right? Third is endogeneity, because so what is endogeneity? Endogeneity in technical firms, as my technical colleagues here, analytics colleague here would know, is that when you model but we are not extracted the entire information from the data, that's when the endogeneity exists. And what really means is that if I see the correlation between input and the error term, I will still find some correlation. That means there is some information is still left in the data which the model has not learned. Neural network being over parameterized, being having been able to go into granularity, can overcome endogeneity, right? And we'll see that in the subsequent slides. The next problem is interconnectedness, right? I've been telling that everyone assumes the siloed impact of media variables, but we know that as a consumer, we are exposed to multiple media factors, right? My decision as a consumer is a combined impact of multiple media exposure as well as non-media factors, not only media factor, non-media factors, right? We need a model that can comprehensively take media as well as non-media input, figure out the interconnected impact of all these variables, and then model on the sales data, right? That's the right model. And that's where we'll get the true insights, right? But that's not been happening in the machine learning algorithms. And therefore, we case for deep learning here, right? And finally, I think in the analytics world, we know the multicollinearity, right? And we all probably get afraid of multicollinearity. We know that some of the media investments might be put together and multicollinearity might exist, etc., etc. And therefore, people always want to handle multicollinearity, right? I want to make a statement that if it is deep learning and neural network, we don't actually need to handle multicollinearity. And I tell you why. Multicollinearity, by its name, is collinearity, right? That means the way the multicollinearity is measured, it measures the linear relationship between input and output and within the inputs, right? More so within the inputs, right? And therefore, but when the neural network models, they take the non-linear relationship among the inputs and its impact on the output. And therefore, the entire argument of multicollinearity goes for a toss, right? Therefore, neural network is also very good in handling multicollinearity. These are all the issues that have been existing in the industry. And that's where the DataPoem comes with its revolutionary DataPoem platform. And we are solving all these challenges. And happy to tell that we probably have made very, very good progress in solving all these challenges, right?
Yeah. So to just connect back to the business problem from a marketing planner or a analytics person, right? Because of multicollinearity, we are not able to take as many features as you would want. Because of interconnectedness, you are not able to understand the impact of one feature over the other. It'll have a problem in forecasting. It'll have a problem in the understanding cross-channel synergies, and hence you'll get a lesser ROI. So all the business problems that actually we go through as analytics teams or business teams is primarily coming from the limitations of Esterier's learning technique, which is still kind of being used, right? And that's what we want to move away from to actually find a solution forward, right? So that's what we went with. Yeah, Chinmay.
Right, right. No, thanks, Bharat. So what is happening today and tomorrow? I think the answer is simple. We are having causation. We are able to achieve causation, able to figure out the causal relationship between input and output through neural networks and other techniques, causal AI framework that I will talk about later in the slides, and which can take care of interconnected impact, non-linear impact, and in fact agility also, which also we'll talk later in the slides, right? So that's where the DataPerm platform is uniquely positioned, and we are here to make a dent. Right. Having talked about what DataPoem platform does, etc., etc., I think it's time to deep dive about what is our framework, what are the 4 pillars on which the causal AI framework of DataPoem sits on, right? I think first is input data. I'll talk about them. Then comes because input data is very, very important. If there's garbage in and garbage out, no matter how good the algorithm is, if there's a garbage in, we'll get garbage out, right? Input data. Deep neural network is the second pillar because we believe, like I've been telling, it helps us understand nonlinearity, interconnectedness, and many other stuff that the traditional algorithms have been failing at, right? The third is causal AI, right? We all have this notion that AI is black box, black box. At Data Poem, we have opened up that black box through causal AI, right? And we can actually understand what's happening within the network. If there's a certain prediction, why that prediction exists that way, what are the factors influencing that prediction, what are the inputs that influencing that prediction, and how the inputs are interacting with each other to make that prediction. Even that is that is an output from our platform using the causal AI module, right? And then finally, our like I was saying, our models are absolutely explainable, transparent, and they you can prove if there's a prediction, we can explain why the prediction is the way it is, and one can open up the logic and see what is going on inside the neural network. Now, why is this important? This is very important for any business person to trust what's going in the AI model, right? If they don't know what's going in the AI model, even if the prediction is right, for him or her to take actions based on the learning and the recommendation from this model will be very, very hard. We have understood this, and therefore, causal AI is at the heart of everything that we do here. Right. We can delve further in the input data part. So like I was telling that the data has to be absolutely there, and not only media data, because when we want to model against the sales data, sales is getting impacted by multiple factors, media as well as non-media factors, external factors, right? At Data Poem, we take all this data as input and make a model which is comprehensive enough, right? That's point number one. Point number two, whatever data that we get, we are very, very particular about it, about its quality, about its frequency of receipt, and its validation, etc., etc. Because while we might have a cutting edge algorithm, like I mentioned, the data also has to be equally good. Then the combination works the magic, right? So data hub is we take data across media, non-media. Within media, we have online data, online media, offline media, e-commerce media, Google Ads, Amazon Ads, influencer, affiliates, event-based marketing, everything. Everything that a CMO would do or company would do, or any marketing activity that is undertaken by them to increase sales can be an input to our model, right? And that's how we have been working. Sure. No, thanks. And I think, sure. Having talked about input data, the second pillar is the deep neural networks, right? Most of us might know neural network, I'm sure. Let me anyways take and understand and explain what is a neural network through a simplified presentation on this slide. What you see is a simplified representation of neural network. Here, the input data is the bottommost layer, and the output layer is the topmost layer, the black dot that you see. In the technical language, as we know, these dots are known as neurons, right? So in the input layer, in the bottom, the granular data is getting ingested. For example, not only the impression of digital video, but within digital video, what is the impression of Facebook? Within Facebook, what is the impression of a particular audience, right? That granularity is getting used and that data is getting ingested. And we know that there's an in-stock impact because the impact that happens today is because of the media exposures over last few days, last few weeks, right? So even this neural network take care of that time series phenomena, right? And model that, and then try and predict the sales for the brand, right? And that's how this neural network works. In this neural network, during the training, what happens is these weights and biases at every neuron get trained, and the weights and biases are iterated through so that the error in the prediction from the topmost neuron is the minimum. And what that does is it forces the network to find the optimal path towards the output, right? And therefore, here in this representation, if you see this black lines is basically the optimal path during training, which the model has learned that's how for a particular prediction these input data are making more impact than others, right? That's how the model learns, right? And there's a nonlinear activation function sitting on this each of this neuron, which helps understand and learn number of non-linear relationship between input and output, right? And each neuron here is getting exposed in the middle layer. The neurons in the middle layer is getting exposed to the inputs from multiple neurons in the penultimate layer. So each neuron in these hidden layers get to see multiple media activities and they can learn the interconnected impact. So that's how, in nutshell, the network learns the interconnectedness, it learns the nonlinearity, it produces, it can handle multilinear data, multilinear data, and then it can, because we are having a very, very comprehensive data input, it makes accuracy which are 90% plus, right? All these factors come together to give us 90% plus accuracy. Yeah. All right. Having talked about deep neural network, I think let me build the cat, come to the more pertinent question here. All right. So, but how the causal AI? How causal AI is getting executed here, right? For that, we have borrowed the causal ladder framework by a famous scientist, Julia Pearl. We know Julia Pearl is a Turing Award winner for its contribution in probabilistic and AI field, right? And there's a very, very interesting book by Julia Pearl, The Book of Why, which talks about the causal ladder framework to causality, right? What is this framework? This framework says that there are 3 steps to causality. The first step is association, that is just verifying whether an association exists between input and output data, right? This is association, right? Having verified that yes, there is some association that exists between input and output, then we move towards the next legs, which is intervention, doing that. If I do this, what happens? If I do that, what happens, right? And we understand and study that impact. And finally, counterfactual, right? Which is imagining. If we imagine TV is not existing, what happens to the output? If we imagine something else, what happens? Like it's imagining counterfactual scenarios and then figuring out how the model, what output model gives, and based on that, it figures out the causal impact between input and output, right? So that's how the entire framework to causality works here. And through counterfactual methods, we can actually figure out the causal impact of each input on the output, right? And also how this each input is interacting with each other, right? And making a combined impact on the output. Right, fair enough. Yeah, we can go to the next slide. So when I talked about the association, I want to delve deeper into how our platform does this association work, right? We know that modeling marketing mix is not a point-to-point data modeling. It's not it's not a modeling of spatial data. It's modeling of time series data, because the sales or any other KPI, which is the target variable, is also time series. It is running. There's a value every day, and the value every day is a function of previous days, right? And the media input is also a time series data, which is running on the time scale, right? So for the causal framework to work, we need a framework where we can find the causality between time series data and not just a simple data, right? And that's where the granular causality helps us do that, right? The granular causality use the autoregressive models to model the causality. However, the way we implement granular causality, right? Because we implement in the non-linear way, not a traditional linear way. We implement non-linearity of the granular causality using the non-linear neural network models. And that's how we can check the association, not just the linear association, but the non-linear association as well. And that's when we can actually get the real association between input and output. That's why the neural network works wonder here, right? We can go to the next slide now. Now, talking a bit about counterfactuals, right? Having established this association, right, between input and output, but even if a variable like say TV is impacting the sales, we want to know how much impact is there, right? That's where the counterfactual comes into the picture. And in data platform, the counterfactuals are executed through missingness, right? Let me explain how. On the slide, on the left-hand side, you see, let's say there are 3 kinds of media which are on: TV, digital, print. All of them are on, and we experience certain sales in the market, right? What if I switch the TV off and let digital and print be still there, right? We will certainly see some drop in the sales if TV has causal impact on the sales, right? And if there's a drop in the sales, number one, TV has causal impact on the sales. Number two, the extent of drop is the amount of causal impact of TV on the sales, right? So that's how the counterfactuals is a powerful framework to not just establish the causality, but also the amount of causality, right, between input and output. It might be, on the slide, it may appear very, very nascent or simple that, okay, there are three variables. I will switch on, switch off, one of all of them in silo and in combination, and I'll get the attribution. But assume when we have multiple such variables in the models and all the variables have to handle together, and I need to get the attribution at each granular input, right? That's where the complexity happens. But that's where the beauty of data platform, that it handles that complexity very, very beautifully and give us absolutely robust output of the all attribution of the counterfactual using counterfactuals, right? All right. Yeah, right. I think so we talked about the modeling aspect, we talked about the data aspects, we talked about the neural network, etc., etc. This is an important stuff is that industry largely is still stuck in that half yearly or yearly cycles, right? They are still building models which are updated either half yearly or yearly. And we know that how dynamic the world has become, right? The consumer response to the media exposures changes every day, every month, every week, right? We cannot just have a model which has a learning of 6 months old or a year old learning, right? We need a model which refreshes maybe every month, right? Or quarter, right? So that our model has always up to date pattern of input and output, right? And therefore, a very, very powerful way we do our models is through agile learning, and wherein we just don't make models once, right? We keep updating the models at regular intervals with the newer data that is coming in, right? So the newest learning is always available and factored in the model, right? And therefore, not only that helps us get the near real-time ROI of each factors, because if I update my model very frequently, even a media activity or tactic that got introduced very recently, I can measure the ROI of that tactic. So it just helps me make my decisions more dynamic. Just not only that, I think it also helps us plan for the future across all the media variables with the latest learning available, right? And with this dynamic world, this is imperative. I don't think we can rely on those half-yearly or yearly updates anymore. The world has to move to agile learning. The model has to be updated more and more frequently, right? But there's a challenge here, right? It's very easy to say that let's update the model every month or quarter, etc., etc. But with neural network, when we try to do that, there's a concept called transfer learning that we use. And using that concept, we try and make the learning agile and use the same version of the model and incrementally train on the newer data. But there's a risk of catastrophic forgetting in this transfer learning. Let me try and explain that. Let's say that I got a model as of September, right? And then I incrementally train the model on October or November data, right? Now, I need to make sure that the model doesn't learn, while model should learn the learning of September and October, it should not forget the learning until August or until August, right? The last version of the model, right? And that is a very, very challenging task. And that's where, again, data platforms innovation has mastered that art, that it balances between the earlier learning and the recent most learning, so that the model is always balanced in terms of learning of previous and the recent most data patterns. And that's where it is, and therefore it works wonder for our clients, and their models are always updated. They can plan for future using the updated learning, and I think it does wonder for our clients, therefore.
Okay.
Yeah.
Awesome. Okay, we can just touch upon.
I can touch upon that very quickly. I think one of one of the demand that we get from the customer is that while there can be a national model using national data, but we know that for a big countries, let's say for US, the regional variation also makes huge impact, and therefore there could be a demand of making regional model. The good news is that in our platform, the we don't only make the national level models, even the regional models get automatically made, right? With the same data that we have, right? We get the regional cut of the same data and we make the regional level models offline as well as online sales models, right? So it's not only regional model, it's within the region, online sales model, offline sales model, and therefore then we can aggregate the output of all these models and look at the picture at national level for the top leadership, or we can go granular at local level for actionability within that region. Yeah, that's all.
Good. Thanks, Chinmay. I know there are, Tom, are there any questions from the audience? Otherwise, there are some questions which for
Yes.
sure.
So we have about 5 hours worth of questions. You'll be happy to know that. But I'll narrow it down to some of the big ones. How's that for you, to make it very simple for you? So one of the questions that came out was, we're talking about neural networks. Now, what I've heard, and also what my boss has been telling me, is that neural networks is more like a black box, and they've tested it in the past, but haven't been able to quote unquote tame it. I'm not sure exactly what the definition of tame it means based upon the input from the person, but the difficulty in terms of what is actually happening in that black box. What does Datapom do differently to be able to open up that Pandora's box and allowing clients visibility in there?
Right. No, interesting question. And maybe I touched upon that in my presentation, but I has to emphasis more on that because it's a very, very common question even when we speak to our clients, right? Because there's a traditional belief that the AI models are black box. And when we say that we open up the box, there's an air of disbelief. And I want to take this opportunity to explain how we do it, right? So that people believe that the way we are opening up the black box is the right way of opening up the black box and understanding the inner mechanics within the models, right? And the way I explained in the earlier slide using the Julia Pearl's causal ladder framework, because that's a very powerful framework which helps us establish association between input and output. And then using this counterfactuals, it helps us estimate the causal impact of input and output. Like I explained, in the left-hand side, if I have 3 media exposures, TV, digital, print, all of them are on, and I'm experiencing certain amount of sales. If TV has causal impact on my output sales, and if I turn TV off, I should see a drop in my sales, right? If I'm not seeing drop in my sales, then the TV is not causally impacting my sales. And if I do see the drop in the sales, that means TV has a causal impact on the sales, and the amount of drop is the extent of causal impact of TV on the sales. And like I mentioned, the data platform does it beautifully across hundreds of variables, right? Not just 3. And that's where the complexity exists, right? But we have beautifully solved for that. And that's why that's how we have opened up the black box and peeped into it.
Great. Another question was around siloed intelligence, right? So the question came back was, we have this big data lake, or more of a data dirty puddle within our organization. So we're getting a lot of data in there. It's not harmonized, it's not clean, but we have it all kind of centralized overall. The data is then used for individual purposes, right? We have trade ROI, we have shopper marketing, we have market mix modeling, and so forth. Yet we're not necessarily seeing the overlap in between all of these different elements, which right now is working for us. But we know that the next step would be to take a look at that. What are some of the best practices in terms of cleaning up that hairball and then being able to integrate all of those disparate models that we have so that it's cohesive?
Yeah.
But you want to take this?
Yeah. So, one of the biggest challenges when we talk to a lot of our clients is from, moving from a present a descriptive statistical world to a causal AI world is the notion of, hey, do we need to replace the whole system, which is practically almost impossible to do it. Uh, and that's where we almost recommend an approach, what we call as augmenting as a first step, or supplementing the existing models using causal AI, and then eventually transitioning into causal AI world, right? So what happens with augmentation is that you actually get your synergies, your long-term ROIs, your granular ROIs. You can get it on a monthly level, basically the agility of the model, and then eventually you can move into a pure play causal AI model, right? In as a slow transition, and not move from, hey, from a statistical model, you don't have to replace the whole thing. So what we do is we have a product called Your MMM to the power of data poem, which is primarily taking your model and kind of building AI on top of it, so that you can actually get all the benefits of your of maintaining the existing system using the same data sets, and actually building or augmenting your model with supplementary uh, insights, as well as capabilities that your present system is lacking.
Got it. Last question for you guys, so I can let you guys go. One is, Chinmay, you mentioned about learning model, right? So building the base model and then have incremental
Yes.
model updates across the board. So we're actually getting that, and we're getting it every 6 months. And then we have the ability to look back, right, in time, to be able to look at January, February, and March. What's the differences that you're seeing in terms of the deliverable, the timing of the deliverables, the frequency of deliverables? Because we do feel as though that it's questionable in terms of some of the data that we're getting, whether it's actionable, being 2 to 3 months, 4 months late in certain aspects, to be able to make it more actionable for us. What is the pacing that we would see?
Right. No, and thanks, Tom, for asking that. Basically, what happens is that the earlier paradigm of making a model half yearly or yearly level has a lot of challenges and limitations, right? I tell you why. On one hand, you have this consumer response to the media exposure that is changing very fast, very dynamic, right? The way a consumer would probably respond today will be very, very different. It happens next month or next week, even, right? So the consumer response to these exposures is very, very dynamic on one hand. On the other hand, the strategy the media planners are adopting, I think they are also very dynamic in terms of adapting their strategies, trying out new tactics, trying out new campaigns, right? And they are very impatient to measure the impact of those campaigns as fast as possible so that they can course correct. We are all in the world of agile action, right? We cannot take an action today and then see the result of that 6 months or a year later, right? We want to see the impact tomorrow, right? So that day after tomorrow we can course correct. So the data poem paradigm of agile learning has, on one hand, helped the models learn the recent most consumer response to the media exposures very effectively. And on the other hand, it has helped the media planners, right, to understand the impact of the dynamic shift that they keep doing in the marketing strategies in terms of introducing a new strategy or a new tactic, etc., and see the result very fast, right? Third, we also keep launching the new products, right? Now the new products are getting launched at a very, very fast pace, right? We want to know that what media would work for these new product launches, right? And we cannot wait for 6 months, 1 year, right? We want to know the results again, like tomorrow, right? So that we can course correct, take actions, right? So I think all these reasons, the agile learning of us is very, very well taken by our customers, right? And they appreciate that when we give them the frequent outputs, they can see the ROI like a baseball score, right? It's like every month there's a score which is coming, and they can see it's going up and down, and they can figure out what should be the course correction, therefore, based on that score, right? And it helps them optimize for future, right? For course correction. And I think that's very well taken, therefore.
And also in terms of velocity of outputs, we actually give them, let's say on a monthly level, if the campaign finished in October, we'll be giving them by November 15th to November 20th in terms of
Absolutely.
outputs, right? So that way they have very, very uh, most
Fast
updated
visibility.
model with the most fastest way to get that output.
Absolutely.
Right.
Thank you. I'll let you move on. There's two
Yeah.
or three more questions that we can answer at the end
Yes.
if we have time.
Yeah. No,
One last
that's very.
question which we get,
Yes,
which is about
absolutely.
overfitting. You want to take it
Yes.
up,
I
Chinmay,
want to actually
because
delve further on that is that there's a common notion that the neural networks are over-parameterized. They're over-parameterized because there are many neurons in the network. And when we make the model, the platform actually iterates through the number of layers, number of neurons, etc., etc. So there's a notion that there are so many neurons and there's so many parameters, right? And if a model works with those many parameters, it is likely to overfit and not generalize enough for a long-term forecasting. But we have seen in our practice, because we have built model and we have seen the accuracies of 12 months out, that even for 12 months out horizon, they're the forecasts are very accurate. And the same is backed by the research also, right? Research says that there's a phenomena called flat minima or double descent phenomena, right? Which actually is that when we train the model, what are we doing? We're trying to optimize the neural network, right? The parameters of neural network so as to minimize the error. And when we do look at that error curve, right? That error curve becomes flat with neural network. Now, what this flatness does is that the it provides robustness to the learning of the network, because even if the neural network doesn't reach the absolute minima, and even if it hovers around at minima, the results don't change much. They are very robust, right? And therefore, it actually does not overfit the data. It actually, because of neural network, it generalizes much better on the data which it's trained on, and that generalization leads to a very good forecasting accuracy even for the periods which are 12 months out in future, right? And we have seen, and that is also backed by the research here, right? You're right. And there are a couple of more if we go further in the research, like there's double descent phenomena which says that classical machine learning, for up to a certain number of parameters, the performance improves, and after that it degrades. But in the neural network paradigm, because of the double descent phenomena, even as you increase the parameters, the results keep improving, and it doesn't go worse. So all
yeah.
this
So
research suggests that.
our experience is that we get, even after 12 months, across seasonal categories, non-seasonal categories that we build with, we kind of deliver close to 90% plus accuracy after 12 months. So quickly, I will take you through one case study of what, Chinmay has been telling, the power of Causal AI and how it actually worked for a brand, right? Like we said, we can actually build uh, outputs both for short term as well as long term, and you can understand, each channel and each tactic will have different ROIs, and the system is able to provide both the short term ROI as well as the long term ROI in one single model, so that you can actually figure out what is the best allocation of investments against brand campaigns, performance campaigns, special events like Super Bowl. That's a big advantage and the impact of a causal AI framework. The other important one is in terms of granularity. We almost provide close to 6 to 7 levels of granularity, starting with the brand campaign that you would see at a brand level, then moving into campaign types, then you can do into different levels of media, which is earned, owned, and paid media. And then you can go further down into different kinds of channels in media, which is TV, print, outdoor, digital events. And then you go further down into channels, which is social, video, display, cable, which is for TV. And then you move into the individual platforms and the audiences or the creative campaigns that you're using within those tactics, right? It gives a very robust, granular ROI at a tactic level, going up all the way to the brand level, so that the system can optimize at a brand campaign level, at a media type level, at a platform level, and an audience level, right? Basis this, we've created optimizations for a brand, which is across not only for at a media type level, but also at a channel level, which is, like I said, social video. Then you move further down into platforms and move them further down into audiences, which gives a very, very high level of actionability as well as increasing ROI on an ongoing manner. Basis this, the brands are able to achieve a good 6% increase in brand saliency, which is a long-term effect, and also able to increase the overall marketing ROI by a 13% because of the optimization they're able to do it on a monthly level. And in terms of accuracy that we were talking about, we're able to deliver close to 92% accuracy for this brand, which is a seasonal food brand. And hence, the brand teams are now confident about actually implementing the recommendation and decisions as they go along. And that helps in creating a new, actionable, agile paradigm, all powered by Causal AI, right? So the way we see the world moving into is a connected intelligence world powered by Causal AI, which helps organizations move from a static insights world to a prescriptive, actionable decision-making world in an agile manner. And that's what we believe is the future. And that's what Causal AI actually powers the organizations with. Yeah. Any questions? We can start taking the questions.
I have one last question, Bharath, which is more of a broader based question. When we think about this, when an organization just starting out on this journey to more of a connected and data-driven intelligence platform across the board, what are some of the suggestions? What are some of the best practices? What are some of the things that you've learned while going through this process? And it's the good, the bad, right? There's always nothing perfect, right? When it occurs to that. But what have you found as some of the best practices for people to be able to deploy this effectively?
Yeah. So what we've realized is that we always found that there is always a progressive champion who is championing this transition, right? Everyone knows that it can't be replaced overnight and you can get all the benefits overnight, right? But the beauty of this, or a progressive organization will understand that you don't have to replace from day zero and prepare a proper road or a path to deliver or move into this new world. So important thing for an organization is to find that champion who is willing to go and get into the new paradigm, then work with partners like us to get the data ready, which is already there with you guys because you're already doing models. Use that data and the model and transition into a first step, which is I call the transition phase, where you actually augment your model or supplement your model to kind of build these additional capabilities that you need to get, like cross-channel synergies, long-term ROI, to get your granular insights, get it on a monthly level or a quarterly level. So get that level and then eventually move into the next phase, which is the actual pure play Causal AI world, which automatically happens as you go along and do these models and forecasting and optimization. The brands and the business automatically transitions into this new world in a very smooth manner, right? So that's what the ideal way to do it, to just augment it first and then kind of transition into the final state.
Fantastic. Chinmay and Bharath, we really do appreciate you taking the time. It was a very thorough, in-depth presentation. We also want to thank all of our attendees on this session. We hope that you found it informative. We'd love your feedback in terms of the presentation and what your thoughts are. And hopefully how we can actually evolve the presentation in the future. More importantly, we'd also like to see you at the next session so that you can learn a bit more about connected intelligence, because quite frankly, connected intelligence and AI is not going away. And traditional models and paradigms that have been running the industry that we're currently in are going the way of the dodo. So it's important for us to really start looking forward and learning more about some of the new technologies that are coming down the pike. With that, I want to say thank you from myself and also from the Datapalm team. Take care, have a wonderful day, and we will talk to you hopefully in 2 weeks.
Thanks, everyone.
Thank you all.
Thank
See
you.
you soon again.